All right, let's dive right in. Today, we're going to unpack a really big question. What does it actually take to build an enterprise that's truly ready for the future? We're going to start with the absolute bedrock principles for surviving the data challenges we're all facing today. And then, we'll look ahead to the kind of architecture that's going to define the next decade.
So, let's start with a number that puts everything into perspective. $13.2 trillion. Yeah, trillion with a T. That's the projected global economic impact of next-gen network tech like 6G by 2035. And look, this isn't just about getting faster downloads on your phone. This is a fundamental shift in how our economy works, and businesses absolutely need to be ready for it.
So why the huge investment? What's driving all this change? Well, it all starts with a challenge that pretty much every single business is wrestling with, what we can call the modern data deluge. The sheer volume, the speed, and the complexity of information today has completely changed the game for how we have to build our applications.
You know, this problem with massive scale isn't exactly new. As Martin Kleppman points out here, the internet giants, your Googles, your Amazons, they've been fighting this battle for years. It forced them to literally invent new tools because the old ones just broke under the pressure. The big difference now? This isn't just a problem for giants anymore. It's a problem for every successful company out there.
And this brings us to a really critical concept: the data-intensive application. See, for the longest time, we were limited by how fast our processors could run. That's just not the bottleneck anymore. The real challenge, the real headache, is managing the tidal wave of data itself. How much of it there is, how messy and complex it is, and how fast it's changing. This is the core problem that every future-ready enterprise has to get right.
Okay, so if that's the problem, how in the world do we solve it? Well, the good news is we have a proven playbook to draw from. These aren't just trendy buzzwords. These are the foundational pillars for building systems that can actually stand up to that modern data deluge. It really all boils down to these three big ideas, coming from Kleppman's incredible work: reliability, scalability, and maintainability. Now, they might sound simple, but let me tell you, getting these three things right is the secret sauce to building systems that don't just work today, but actually last. Let's break them down. First up, reliability. And here's the key thing to understand. This is not about preventing failures. Why? Because failures are going to happen. It's a fact of life. Hardware will fail, software will have bugs, and yep, humans will make mistakes. In fact, studies show that simple operator configuration errors are a leading cause of major outages. So reliability means designing your system with the expectation that things will go wrong and it just keeps on working correctly anyway.
Next, we've got scalability. This is all about answering one simple question: what's our plan for growth? It's not about massively over-engineering for some far-off future that might never happen. It's about having a clear, sensible strategy for how you're going to handle more data, more users, or more complexity without the whole thing just grinding to a halt.
And when we talk about that scaling plan, there are really two main ways to think about it. You can scale up, which is also called vertical scaling. Think of that as just buying a bigger, more powerful server. Or you can scale out, which is horizontal scaling. That's where you distribute the work across a whole bunch of smaller machines. It's often called a shared nothing architecture. And honestly, most great designs use a smart mix of both.
And finally, we have maintainability. Now this might be the unsung hero of the group, but it's so important for long-term success. A system is maintainable if it's just easy for people to work with. It's about simplicity. It's about good design. The goal is to make life better for the engineers and ops teams who are in the trenches with it every single day. Because complexity is the enemy of progress. So, we've got our principles: reliability, scalability, and maintainability. Awesome. But here's the catch. To really apply them at the kind of scale the future is going to demand, we can't just keep building better software on the same old foundations. We need a fundamentally new kind of architecture underneath it all. So what does the network of tomorrow actually look like? The core idea, which comes out of some really fascinating research into 6G, is this: the future is not one single monolithic network. Not at all. Instead, it's a network of networks. A flexible, super adaptable patchwork of different, specialized network solutions, all working together seamlessly. And this diagram here, it paints a perfect picture of that vision. Take a look. You can see it's not just one big cell tower trying to do everything. You've got dense networks for urban areas, you've got specialized links for things like high-speed trains, and you've got connections reaching all the way up to satellites. It's a totally flexible system designed for a world where connectivity has to be, well, everywhere. Let's break down what we're looking at. This interconnected fabric is made of all these specialized parts. You have your local networks for, say, a factory floor or a university campus. You have mesh networks that let devices talk directly to each other. which is huge for IoT. And then you have these non-terrestrial networks using drones and satellites to guarantee coverage in even the most remote places. And the glue holding it all together? A cloud-native core. This is what it really means to design for the edge.
But a network architecture this complex creates a brand new challenge, right? How do you manage all of it? And the answer is not to just throw more people at the problem. The answer is to make the network itself intelligent.
This is a massive shift in thinking, so it's worth repeating. The future enterprise won't just run AI applications on top of the network itself is going to become a distributed AI platform. Intelligence will be woven into the very fabric of the network, used to automatically optimize everything from radio signals to resource management.
And that leads us to this incredibly powerful new model, AI as a service, or AI as AS. Think about it. The network stops being just a dumb pipe that carries data, and it starts offering up intelligence as a utility. It provides AI capabilities not just for its own internal operations, but also as a service that developers can tap into to build completely new kinds of applications, leveraging these powerful AI services right from the cloud.
Now, to make this a reality, the network needs some new tricks up its sleeve. It needs new, built-in functions to handle the entire AI lifecycle. We're talking about a repository to store and share AI models, distributed training functions to learn from new data across the network, constant monitoring to check performance, and intelligent agents that can execute tasks all on their own.
Okay, let's bring this all back down to earth. What does all this mean for you today? How do we connect these foundational principles with this pretty wild, forward-looking vision to actually start building that future-ready enterprise right now?
The big, central takeaway is this fundamental shift in thinking. The old way was to rely on one giant, do-it-all monolithic database. The new way is to unbundle that. You break it apart into a system of specialized, composable tools. So instead of a static database you query, you start thinking in terms of data flow, of event streams that move through these specialized components that do one thing really well, like storage or indexing or processing. It's just way more flexible, way more scalable, and a lot more resilient. And all this leaves us with one final big question to chew on. The old model of data architecture was reactive. You'd ask a database a question to find out what happened in the past. But by building our systems around this idea of data flow, around embedded intelligence and these future-ready architectures, we can start to build systems that don't just react. They predict what's coming next. So the question is, which kind of enterprise are you building?